Thank you very much for attending this session. Today I'm going to go through some problems on mean absolute deviation, MAD, tracking signal, TS, mean square error, MSE, mean absolute relative deviation, MARD. That is a name I have made it myself, MARD, but generally people recognize it as mean absolute percentage error. I thought MARD is closer to MAD and it has only one additional word, mean absolute percentage error, mean absolute relative deviation. They both have the same meaning. And then I use these things to explain standard deviation of forecast. Some very simple problems on these topics. Please go through these slides. If you have questions, bring it to our Zoom sessions. Please note that all Excel sheets within these PowerPoint slides are active. So if you double click on them, they open themselves and you can edit them, you can do computations. At the same time, you can right click on them and open the Excel object. But if you do this second one, you need to be sure that not to save it. Indeed, after you do your computations, you need to close the Excel sheet and close the PowerPoint file without saving anything. Otherwise, if you have a little bit mixed things up, they will remain over there in your PowerPoint slides. One other recommendation I have, especially if you are going to use Solver, is when you open the file, select on, open a new Excel file, paste it all over there. We are going to talk about forecasting errors. Error is the difference between actual and forecast. So by convention, we write the actual first, then forecast. Actual minus forecast, that is error. Absolute deviation is absolute value of that error. Mean absolute deviation is average of these errors over all observations. Forecast for the next period using moving average, it is moving average of this period. Moving average of period T is used as forecast for period T plus 1. And MAD or MSE or MARD, indeed 1.25 times this, or square root of this, or 1.25 times this. These three can be used as standard deviation of demand in the next period. Forecast for next period equal to moving average for this period. Standard deviation is MAD, MSE or MARD of this period after some manipulation for the next period. If you are using MAD, standard deviation of next period is 1.25 MAD. MAD of what? MAD of this period. Tracking signal is summation of errors divided by MAD. MAD is always positive because it's average of absolute values. And summation of all errors, if you have a good forecasting technique, should be very close to zero, because sometimes actual should go above forecast, sometimes forecast should go above actual. And we said never they can be the same. They are the same in very rare situations. Otherwise there is a difference, but the difference shouldn't show any pattern. Therefore, if it is up and down, when we add them up, the summation of errors should come out zero. Square error is just take the error and square it. So we have two ways to remove the sign in front of error. One is absolute value, the other one is squared. Mean squared error is just average of those squared of errors. Forecast for next period, again here is moving average for this period. Standard deviation of the forecast for the next period is SQRT of MSE. MSE of when? MSE of this last period. MARD instead of averaging absolute values, each one we divided by actual. It would be relative to actual. Absolute error relative to actual, and then we average them and we call it MAD. 1.25 MAD is our standard deviation for forecast for the next period, but it is in terms of a percentage. So for MAD, MAD, these are our actual data. Suppose these are our forecasts, and therefore we look at the gap between actual and forecast and we drop the sign because we don't want these values and these values, these values and these values cross each other's out. If one of them is positive, the other one is negative. While there is a huge gap between actual and forecast, summation and average of those gaps may come out very close to zero, but we drop the sign by replacing the actual value by absolute value and then average them. Compute MAD and tracking signal at the end of period 4 for this data. We take actual minus forecast, actual minus forecast, actual minus forecast, actual minus forecast. And if they have negative sign, we drop that negative sign and then average them. As simple as that. We replace this negative by positive, and then we have these positive numbers 4, 8, 3, add them up, that would be 15, divided by 4, it would be 3.75, average of those numbers at the end of period 4. Now we look at the actual deviations. 8 and 4 are 12, 12 minus 3 is 9. 9 divided by 3.75, that would be our tracking signal. $2.4 is our tracking signal. Sum of forecasting error and MAD at the end of one of our periods, that means from the beginning up to now, are sum of forecasting error 46, MAD 21. Compute tracking signal. So if we look at tracking signal formula here, it is sum of the forecasting error, which is 46, divided by MAD, which is 21. Therefore, that is equal to 46 divided by 21, and that is 2.2, I think. We have the actual data, and we have two forecasting techniques. Let's call one of them green and the other one blue. Which one is better? The one is better which has lower MAD. So we need to compute the gap between actual and forecast for these two techniques and then find it out which one has a lower MAD, and that would be the better technique. I compute the absolute value between these two. Come here, compute the absolute value between these two, and so on. That is the average, which is 4.66. For the other technique, these two, difference of those two. And the difference between this one and this one. And the difference between this one and this one. Here is formula. All formulas are here. And then I average them. This is 5.66. 4.6 is lower. Therefore, this is the preferred technique. Now we want to solve this problem. I have this data, and the problem first asks me to compute 2-period moving average and 6-period moving average forecast. 2-period moving average start from period 3 when I compute moving average for period 1 and period 2, and then take it to period 3. And 6-period moving average forecast start from period 7 when I take the average of first 6 periods and assume it as forecast for period 7. After that, the problem asks for absolute error. Therefore, in the periods that I do have both actual and forecast, for example, 2-period moving average, I have forecast from period 3, and then I go down to period 24, but for period 24 I don't have actual. Therefore, absolute deviation, absolute error can be computed for 2-period moving average from period 3 to period 23, or year 3 to year 23. For 6-period moving average, it can be computed from period 7, year 7 to year 23. Then the problem asks for computation of MAD. I can compute MAD for 2-period moving average from period 3 to 23, and for 6-period moving average from period 7 to 23. But when I am going to compare these two methods, which is the case in the last part, since for 6-period moving average I have data only from period 7, then for 2-period moving average also I should consider data from period 7 to 23 and then compare these two together. So you can do these computations, and when you are done with one part, you can click on this and you will see the answer. What I will do, I will exit this view and I will double click on this file. It becomes an Excel file. I will go here, period 3 equal to average of periods 1 and 2, enter, and then I copy it down. And here are the formula over there. For 6-period moving average, I should go period 7 equal to average of period 1 to 6 and copy it down, including for the next period. Absolute error for this one equal to actual minus forecast, absolute function, and then I copy it down. For 6-period moving average, I should go to period 7 equal to actual data minus forecast, absolute, and then copy it down. Then for MAD equal to average, this is absolute error, column, so that is G4 to G4. But I put a $ in front of 4, therefore row 4 remains absolute and the second G4 will be relative. So when I copy it down, the first 4 remains 4, the second one becomes 5. And if I copy it all the way down, the first one still is 4, but the last one is 13 here. Don't forget, I should stop here because in the next period, while I have the forecast, I do not have actual. Equal to average of this one to itself, while I make the first row, which is row 8, absolute. Enter, and then I copy it down. Now I can go here and I can double click on this one. Data is over there. And copy this. We can copy it over there, or alternatively, I can go here, right click, worksheet object, open. This is my actual data. This is 2-period moving average equal to average of the first 2 period. Enter, copy it down all the way, equal to average of the first 6 period. And then copy it down, and this is the forecast. 1778, 1773. Then absolute deviation is equal to this one minus this one, But I'm going to do one other thing. I want to lock B. So I put a $sign in front of B. B is locked. And I copy it down. Why I did it? Because now I can simply copy it to the right, and that is B8 minus D8 absolute. So that is why I made B absolute, because when I copy to the right, B remains B, which is my actual data, equal to average of this one to itself, and then I lock 8. So now 8 is 8. Then when I copy to the next one, it will be average of row 8 and row 9. Average of row 8, 9, and 10, and so on. I come down, I come to this point. And then the good news is now, because E is not locked, but 8 is locked, I can copy to the right, and then copy to the bottom. And now as you see, this is average for 6-period moving average. So I have both of them. As we said, when I am comparing two techniques, I should compare them over the same number of periods. So here MAD is 269, here is 326. In this case, for this data, 2-period moving average is better than 6-period moving average. So I'll do with forecast for 2-period moving average. This is my forecast for next period, equal to 1.25 multiplied by MAD for the last period. This is my standard deviation for forecast. My forecast for the next period will have normal distribution. Its average is this one, and its standard deviation is this one. When we compare 2 or 3 or 4 methods to find which one is better based on MAD or MSE or MARD, we need to compare them over the same number of periods. We cannot compute MAD for 2-period moving average, say for 10 months, and for the other one for 5 months. No, they should be compared over the same number of periods. So that is also to show that all our Excel sheets are active and you can access them. But you know, when you open one of them, if you leave it as it is, those changes will be reflected over there. Close the file and open it again, that will go back to the original form. So which one is better? 2-period moving average, 3, 4, 5, 6, 7, 8, 9, which one? We really don't know. We only know that when the number of periods goes down, up and downs will be high. When the number of periods go up, 10 periods, 20 periods, 30 periods, the curve will be more smooth. But which one is better for which situation, we really do not know. We need to compute MAD for different techniques, for different number of periods, and see which one is smaller. For example, for these data, if we compute forecast based on 3-period moving average and 6-period moving average, and if these are the absolute value of errors and this is the average of them, here the average is 159.7 and here the average is 195, and we will go with 3-period moving average. But for these data, we see here MAD for 6-period moving average is smaller. Therefore, here 3-period is better, here 6-period is better. For this data, our forecast is based on 3-period moving average. The average is this number, and the standard deviation is 1.25 times MAD. For this one, 6-period, our forecast is 1540, and the standard deviation of forecast is 1.25 multiplied by this 254. So here the problem asks us to compute 5-period moving average and then compute tracking signal. I quickly do it and show. Right click and ask open the Excel sheet. 5-period moving average, you go to period 6 equal to average. 1, 2, 3, 4, 5. Enter. Copy down. A minus F equal to A minus F. Enter. Copy down. Absolute equal to abs of this. There. MAD equal to average of this one colon to itself and lock this 7 and copy down. Sum of error equal to summation of this one to itself and lock this one 7 there. Copy down. Now this is MAD for everything, and this is summation of error for everything, and tracking signal is summation of error divided by MAD. Enter. Click. Everything is explained over there too. Up to now we talked about MAD. If this is our actual data and this is our forecast, MAD will find the gap between these two, absolute it and average the absolutes. But another measure that we have is mean squared error, which is the square of the deviations that we have, and it tries to minimize this. Therefore, when we consider MSE, mean squared deviation, instead of this line with these characteristics, this line instead of that one, maybe this one is better with these characteristics, with a smaller mean square error. So this problem asks us for computation of 3-period moving average and standard deviation of forecast based on mean square error. If you click on it, it will show you everything. 3-period moving average is the average of these 3 numbers which we considered as forecast for the next period. Then we find the difference between these 2 numbers, that is this one minus this one, what is in column B minus what is in column C, and then we also square it, and this is this number, and I have shown it here. Formula is also here, so that is B5 minus C5 square, B6 minus C6 square. Then I compute the averages, average of this one up to itself, average of this 2 which is this one, average of this 3 which is this one, average of this 4 which is this one, and average of D5 to D9, D5, 6, 7, 8, 9, average of those periods which I put it over here, then to D10, D11, D12, and D13. So the average from D5 to D13 is here. That is this number. That is our MSE. We just compute the average of these 3 periods. The standard deviation of forecast is a square root of MSE. Our forecast for next period has an average of 1782 and a standard deviation of 318 or 319. It has normal distribution with this average and this standard deviation. The next measure that I talk about is similar to MAD, mean absolute deviation, but the difference is it finds the absolute value of the gap with respect to what we have observed in reality. So for example, in the first period, this is our actual data. The gap between actual and forecast is this much. So it divides this height by this height. It is A minus F absolute value divided by A. Here A is this one, the gap is this one. It will divide these two by each other. Here the actual is this one, the gap is this one. Actual is this one, the gap is this one. Actual is this one, the gap this one. Actual is this one, the gap is this one, and so on and so forth. So that would be relative absolute gap, mean absolute relative deviation. That is the name that I have made it myself. People usually call it mean absolute percentage error. Mean absolute percentage error, MAPE. So this blue oval shapes are actual, their height is actual, and these are the gaps, and we compute the ratio of the red divided by height of this one. Double click on it, or I can right click on it. Both of them work most of the time. 2 period moving average. So that's equal to average of these two. That is 2 period moving average, and I copy it down. And all of the formulas are here. Then I find the gap between actual and forecast. Its absolute value, abs. And then I divide this absolute value by the actual. There, copy it down. And then MAD is equal to average of this one to itself when I log the first 4 there and copy it down. So that is MAD for the last period. This is my forecast, my 2 period moving average forecast for the next period, and then standard deviation of forecast is 1.25 multiplied by MAD. This is our forecast, and the standard deviation of forecast is 20% of the average. From 0 to 1 is 0.19. From 0 to 100, we multiply by 100, is about 19%, 9.5% of the average is the standard deviation. So we learned several techniques. In all of these techniques, we compute forecast for the next period. We call it forecast for the next period, but it is the average of the forecast for next period. That is forecast for period T plus 1. If the current period is period T, we need to use MAD, MSE and MARD of period T to compute the standard deviation of forecast in period T plus 1. Standard deviation is 1.25 MAD, 1.25 MARD, and the square root of MSE. We talked about tracking signal. If there is a good forecasting technique, sometimes it is more than actual, sometimes less than actual, more than actual, less than actual. Therefore, if we add it up over some periods, summation should be equal to 0, around 0, up and down. But up and downs should compensate for each other. Therefore, tracking signal usually should be around 0. If it is up and down with no known pattern, that means we are fine. We are within an upper control limit and lower control limit. Well, how much is upper control limit and lower control limit? Some books say they are 3.75 and minus 3.75, but that's not correct. It can be anything, 5 and negative 5, 10 and negative 10, 20 and negative 20. But we should find it out, what we consider upper control limit, lower control limit. Beside that, what is very important is we shouldn't see any pattern. Here I see a pattern. Tracking signal continually is less than 0. What does it mean? That means A minus F is less than 0. So if I take F to the other side, it is A is less than F. That means our forecasting technique always tell us something which is larger than actual. What about this? This one, A minus F is greater than 0 because 0 is here and that is greater than 0. So that means A is greater than F. Our forecast is always less than actual value. We underestimate. Here we overestimate, here we underestimate the demand. Here demand is more than what we think. Here demand is less than what we think. What is the problem with this one? We see a pattern, a seasonal pattern. That means in reality there is a seasonality, but in our forecasting technique there is no seasonality pattern. We have missed that part. We have not been able to forecast seasonality. All these three, good. There is a problem with it. This one is good. Thank you very much for attending this session.